packet pushers.
Welcome to the IPv6 Buzz, where we dare to dive into the 128-bit address space wormhole. I'm Ed Horley.
And I'm Nick Buraglio. We discuss everything IPv6 on the show, from strategy, design, deployment, operations, and even internet standards.
And I'm Tom Coffeen. We've spent 20 plus years working with the IPv6 protocol. We work on getting IPv6 working.
And we're here to share some lessons learned and how to avoid common mistakes. We're glad you joined us. Today, we're going to chat about a new RFC proposal about preferring 8781. And the reason we're going to talk about it is because Nick's one of the co-authors. So maybe we do a little bit of background around what the issues are, what we're sort of talking through, and maybe even further history back, because this relates to another RFC, which is 7050. So maybe we start there with what 7050 does and sort of talk about why the heck we even care about that. And then apparently why we don't care about it anymore. And then we can go from there. Let's chat about it, Nick. What's the background on this one?
There's some fun background on this one. So RFC 7050, which is kind of the de facto way of discovering the IPv6 prefix that's used for address synthesis when you have an IPv6 only network. So essentially a workstation asks for a IPv4 only resource. The DNS server sees that it's IPv4 only. It synthesizes a synthetic, I guess, IPv6 address, hands that back so that the host can then communicate over IPv6 via a CLAT and a PLAT, or just a PLAT, upstream NAT64 device.
Mm-hmm.
It's been around for quite a while. I think it's 2013. So it's over a decade old at this point.
More work by Dan Wing. No surprise there.
Yep. And, it's getting a little bit long in the tooth. And Greg Farrow used to always famously say BGP is the garbage can of the internet. And I would say that the recycle bin is probably DNS resolution, right? So like if you can't shove it in BGP, let's shove it into DNS. And when you're talking about network connectivity from a host, you may want an alternative to, say, an external system that may be run by a different group. It's outside of the network, but it's also sort of creating this sort of fundamental piece that you're relying on for connectivity. Maybe you don't want all the eggs in that basket. I mean, most of the eggs are in the DNS basket anyway.
Right.
It's another thing to sort of think about when you're talking about moving to IPv6 only. And there are other ways now that it can be done that are more isolated, I would say. So the blast radius is smaller when they don't work.
Yeah, I think it's a little bit more of the analogy of a chainsaw to scalpel, right? So
that's a great one. Yep.
But I think just to back it up a little bit for the audience, this is the case where you're allowing clients to discover what we call the network specific prefix, as opposed to like the well-known prefix or the well-known prefix that's used for NAT64. So you want to be able to use a very specific prefix to translate out on behalf of the clients that are existing inside your environment to be able to communicate with resources. And so you're doing that with the DNS record. Effectively, you're publishing a DNS record that says like, hey, this is the network specific prefix that you should use, which obviously causes some problems from like a scale standpoint. It also solves some problems, like for smaller businesses. It probably makes a lot of sense to potentially use this because it's very simple, single entry. Everyone discovers it. You're off to the races. It's really fast. It's very effective from that standpoint. But I think if you're in a large distributed enterprise, you might want a little bit more granular control over what prefixes you're using, if you're using the well-known prefix or not using the well-known prefix, where you want devices to do that. And you may want specific DNS scopes and range sets to be configured in one way versus another, which is, to your point, like you might have things that sit in a DMZ that you want them to go through something different than maybe what your end client devices are using. So in part, that was what 7050 was originally about, was just being able to use DNS to publish out what that network specific prefix actually is or what it should be using. Tell me if I'm off on that, you guys, but that's at least my understanding. And you're working on basically some standard recommendations because there's some other methods to be able to do this exact same process, right?
Yeah.
And maybe we talk about what those other methods are.
Yeah. So basically what we've written is a guidance document, so it's in the V6 Ops working group, which I'm one of the co-chairs of. And it's essentially meant to provide a guidance document that says, hey, you can do it this way over here, but also like the preferred methodology is to use, the mechanism provided in RFC 8781, which is Pref64.
Right.
And what that is, that uses a router advertisement on the local segment to provide that same information that you would get from an off-net resource in your DNS resolver, right? So your DNS resolver is very likely not on the same subnet that you're on. If your DNS resolver is on the same subnet, your network's probably fairly small, and there's no real reason other than maybe you want to mess around with Pref64 to change it. Like my office is pretty small. We have like 4 VLANs. It still runs 7050. Again, it's not broken in any way. It's just there's another way that is potentially less resource impactful to do it. That is the mechanism described in RFC 8781.
I think there's a benefit too, in the sense that we kind of have to deal with different silos in the enterprise network side, where this has always been sort of the classic problem. It's like, what do you mean I have to configure a bunch of information on the router interface now? Or, with V4, I never had to sort of think about it in that way. And so kind of centralizing some of those configuration knobs, on the router interface, and who's responsible for that and how that gets instantiated in policy and maintained. There's a bit of a streamlining that can happen there, as opposed to, hey, you got to hand this off to the DNS team, as you say, in a larger organization with DNS that's fairly balkanized. Who knows how many points you're touching at that point, and with a team that isn't maybe necessarily as responsive to what you're trying to do on the local segment.
Yeah, exactly. I mean, it's really a question of where do you want the complexity to be?
Yep.
Right. And there are arguments, for both, and I've used both and they both work fine. There are some caveats with RFC 7050, which, if we want to talk about why we actually wrote this, which I think is probably pretty important, especially for maybe some enterprise customers or, other government entities that may have specific security policy requirements. RFC 7050 has some very vaguely defined security controls that aren't really implemented anywhere. In theory, they could work, but like I said, they're really vague in their definition. I think that was probably by design because, again, this is like an 11-year-old draft or an 11-year-old RFC, which means they probably started it 12, 13 years ago. It takes a while for these things to sort of percolate through the process, but because those are so vaguely, and I would even be so bold as to say ill-defined, it leaves a lot of ambiguity, and ambiguity breeds confusion and inefficiency and, other operational potential problems. So saying like, the preferred method is this method over here, right? The RFC 8781 mechanism, that does a couple things, right? It sort of lays out, this is how, in most environments, you should probably do this. These aren't edicts, right? These are guidance documents. They may have an RFC number, but they're informational. They're not standards. So, I mean, they're standards, but not in the definition that a lot of people think they are. It's like, here's an informational guidance document. So in creating this document, we say, we prefer you do it this way, right? And here's all the reasons why, and here's all the caveats you have to think about when you do it this way. So it tries to be a fairly unbiased document in that it points out like, hey, we think you should do it this way, but here are some potential problems you might run into, or at least some considerations that you have to think about. And one of those is that security mechanism that's not well defined. So because that document is an RFC, people will see the security implications, say, I want that, but nobody does it. Right. And then it becomes a problem. And so that's one of the reasons that we were motivated to sort of make this happen, was to clear up some of that ambiguity.
Well, I think it also helps with the client side because you have both these options available. Which one is preferred by the OS?
Yeah.
From a behavior use basis. So there needs to be some sort of sorted, ordered list that says, hey, use 8781 first, but if that's not available, go check and see if 7050 is available. Okay, 7050 is available. If both are available, because for some reason you check both, you should be using the 8781 method, using the Pref64 from the RA. And if for some reason things go horribly wrong and that's not available, fall back to the 7050 method. But at least we're giving you a sorted, ordered list of behavior that we expect to see within the OS that allows the vendors to make something consistent sort of across the board.
The good news is we've given you a client preference list. The bad news is we've given you a client-based preference list.
I mean, it turns out order of operations is kind of important in networking, right?
Yeah.
We've had such great luck with client-based preference lists with IPv6 in the past.
Yeah, well,
Nick's not working on that at all.
intimately familiar, yes.
But yeah, this is good guidance for folks. And I think it gives operators a good idea of where they should choose putting their effort and time first. So
Yeah.
spending effort and time around 8781 and understanding what they're doing with router advertisements and Pref64 and how they should be leveraging that from a RA basis in their environment is probably more useful. And then there's a whole set of sort of multi-homing discussions and what needs to go on in the considerations around how to do that, because you get a lot more flexibility, at least in my opinion, with 8781 than you do with 7050. I mean, you could build scope zone configurations for DNS for 7050 and go all sorts of crazy, but you're relying on the DNS team to make sure that they're doing all the right stuff for each one of the address ranges that you're potentially impacting to provide different actual network prefix selection.
Yeah.
I don't know how well that would work or not work. I haven't played with that myself to try and set something up like that, because why would you need to if you got 8781? Then you don't need to do that. But I guess in theory, you could technically do that. So
As a recovering DNS admin from the late 90s up until not that many years ago, I would much rather configure it on a router than in Unbound or Bind. Or DNS views are,
how dare you?
I mean, you know,
You want to get rid of views? What are you talking about, man?
I mean, I like views. I don't want to manage them anymore. That's my personal preference. I think they're incredibly powerful. Someone else can run that.
Yeah, send mail CF files were incredibly powerful too.
I've done that too. Oh, yeah. I went through Bind 4 to Bind 8 upgrade at a service provider, and then Bind 8 to Bind 9.
Yeah, you cried the entire time.
And then that was about what told me, like, yeah, I don't know if I want to run DNS anymore.
Well, maybe we talk a little bit about 8781 and what it does, so that puts a little bit more context around what you're actually telling people that they should be preferring or using. Maybe that'll be a little helpful about talking about maybe the Pref64 portion. So what exactly is Pref64 and how is that involved with the router advertisement? Because there had to be a new change for the router advertisement to put this information in there, right? So
Yep.
there's a new extension for the RA in order to be able to support doing this. So maybe we talk a little bit about that.
Yeah, I mean, I'll be totally honest. One of my motivations for being involved in this draft was simply to create that preference so that I could take that to vendors that I need to implement Pref64, because that's still not widely implemented.
Yeah, that's a good point.
It's something that I think is on roadmaps and things like that. And, you know, if we ask for it enough, they'll eventually do it. But it's not necessarily something that is ubiquitously available, like DNS resolution is, right? And so in creating this document, we can say, look, you know, the preferred path for this is, you know, RFC 8781, Pref64. Why don't you support this yet? And can we get, as a former coworker, you say, can we put some mustard on that, get it done? And so that was my motivation, is I want this in devices that I use, right? Because it doesn't exist in a shockingly large number of major vendor equipment. So I'm hoping this will help with that and, you know, a lot of complaining.
Then vendors take note. We're putting our thumb on the scale
Yep.
in regards to which direction things should go. I think that's really good. And this even takes into consideration some of the security concerns around like RA guard and like things of that nature.
Mhm.
So this actually allows you to put some pretty good security controls around how hosts are behaving and how they're getting their information, which I think as we move more and more towards zero trust architectures and the sort of importance around that, this becomes a easier domain to sort of control within a local scope around local isolation in a way that's super helpful and doesn't break, you know, dot or do or any of the other secure DNS methods. So that's what's sort of nice about this. And you can leave that alone for the DNS folks to sort of figure out on their own what needs to happen there.
You brought up a really good point. One of the main drivers of this, because we originally took this, and I think the last time I presented it, actually, it was for the DNS op working group.
Mm-hmm.
Because one of the things that RFC 7050 and DNS 64 does is it breaks DNSSEC.
Mm-hmm.
So that's something that it's incongruent with a lot of security requirements, especially, you know, when you start talking about governmental entities and, you know, higher security leveled businesses. Like, you want to be able to have DNSSEC validation. And if you're moving towards V6 only, what are your options there? Right? It's one or the other, right? I know which one's going to win. and it won't be the one that I want to win, right? So like, how can we sort of level that out and say, look, there's another way to do this that gets everybody everything they want, where everybody is absolutely in air quotes, but that's a major point, and that's why we took it to DNSOP first.
Right.
After that, we kind of collectively decided, well, this is really more of an IPv6 operational thing, so let's kick it back over to the V6 Ops working group, and that's where it was adopted. And I think it's on the docket for the upcoming IETF. We just pushed out a new version of it, so.
Yeah, so you got to present on that. So you'll be up late.
Yeah, I'll be up because I'm not physically going to Thailand.
I guess this is a chance for you to sort of do a pitch to the audience around why they should be paying attention to this and maybe even providing feedback. What do you want to hear and why do you think folks should be paying attention? Give them a reason to go read the draft and maybe not nitpick through it, but at least have an understanding about why you, Tommy, and Jen are all pushing or advocating around this.
So you brought up two things, like the two co-authors are, I'm sort of the plebe over here. We have like Microsoft and Google are the other two organizations that the people that are co-authors, that's their day jobs, right? So like, it's not like this is just random person off the street.
Yeah, this covers 90% of the client devices in the planet.
There's some people behind this that carry a very large bundle of sticks. So please, I think that it's important for people to go read this if they think they're ever going to use it, right? Because what we want and what I want personally is please do nitpick it. Like it needs to be well done. If there's something in there that isn't right, we should fix it. If there's something in there that people think maybe needs improvement, we should fix it. It's not going to hurt my feelings if you say this document stinks, right? I mean, it might, but I won't let you know that it does. So the more people that look at it and the more people that actually go and exercise Pref 64 and they tell their vendors that they need it, maybe because of this or maybe because they just want to try it, I think that's the value that it's bringing sort of as a value add. Providing the guidance is great, but also like it needs to do something. Like it needs to accomplish something that is useful for the community. And so the more people that look at it, the more people evaluate it, the more people that give us their input on it, the better it'll be. It'll be better because of that, right? That's what the community's for.
Yeah, and I think there are probably a lot of enterprise admins out there that they may not be sort of on I wouldn't really call it the bleeding edge, but they're still thinking of V6 deployment in terms of dual stack or just a bit of an eye on the horizon related to IPv6 only and IPv6 mostly. And so they may be playing catch up to some extent with where things are at within the IETF and providing these options, but kind of short of being at a place where they're like demanding it from the vendor. There's still a shift that has to happen for, I think, a lot of enterprise admins that are strange to us because we're thinking about it and we're steeped in it, but they're still sort of mired in a dual stack mindset and not really thinking about what tools they're going to need to run IPv6 mostly and IPv6 only.
Let's pivot on that because you were talking about a good point around the operational model. I think the main difference I see between 7050 and 8781 is from an ops model basis is one's centralized and one's distributed.
Yeah.
Right. So let's talk about the distribution sides just so the audience sort of feels a little bit more comfortable with what's going on there. But because you have a local customer side translator, that CLAC capability, right? And the Pref 64, you would like to do things like, I don't know, translate IPv4 literals to IPv6 literals, which you can only really do if you have a local preference capability, right? That's indicated that way. And you probably want to have some sort of distributed DNS, right? At scale, like if you want to have local site survivability for if it's severed from the WAN or things of that nature, you still need to do translation internally within that local remote office site or large facility. You want to be able to perform local DNS 6.4. And the only way to be able to do that is to have something like a Pref 64 option and to have things that are distributed out versus having it centralized, because having it centralized means that you always have to be connected to that resource. It also means that your traffic's going back to that central resource for many things, including it might be for, the NAT64 portion for that particular prefix that you're advertising, unless you're doing something funky. Like, I guess technically you could do it with any cast, but at that point you're getting more sophisticated. You might as well just do Pref 64 anyway. So I think that that's maybe the crux of the argument around sort of centralized, older school, and having more flexibility to do something distributed. From the ops model, does that sound correct to both of you? I think that sort of helps to break down a little bit of it.
Yeah, that definitely sounds right on point for me. I mean, the way that my mind thinks about it is for whatever reason, I go to like rip stop material, right? So the downside of Pref64 is you configure it on every routed interface, right?
Right.
That's providing RAs. So it's more configuration on a router. Now, on most devices, it's like 1 line or 2 line. Pretty straightforward, right? You can automate that, or I could write you a Perl script to do it, right?
Pearl.
That's right. Dating myself.
Update your CPAN.
Yeah. That's either a plus or a minus, right? Depending on what your expertise lies in and where your resources are available. But if you break that, it only breaks that one. Like, let's say you're configuring on 10 different VLANs, you're doing it manually and you type at one of them, right? 9 of them are still going to work. One of them is going to be broken. It's going to be probably pretty obvious. Well, this is not right. And this is the last change. Whereas if you do it on a centralized DNS server, right, you only have to do it once, which may be easier, right? Depends on your resources. It depends on what you're comfortable with. But if you misconfigure that, not only do you risk breaking DNS64 resolution, along with all the baggage that comes with it, right? No DNSSEC or whatever, which that's just part of the package, but you also potentially break all the DNS64 for every network that's using those resolvers. And also maybe you also break all DNS resolution, period. Because anyone who's messed with bind, when your config doesn't check out, bind isn't running. So there's no DNS. So it's one of those things like, where do you want the complexity to lie, right? I know where I'm comfortable with it. And I'll fully admit some of that's out of laziness because I don't want to run DNS servers anymore. But like, it's one of those things that I think is like rip stop material, right? It'll rip to here and then it'll stop, right? Because that's where the bounds of that particular configuration lie.
Yeah. So you have the blast radius for your failure domain is more granular, a little bit more controlled.
Centralized brokenness versus distributed brokenness.
Yeah, pretty much.
Can we break things at scale?
Oh, trust me, I can definitely do that.
I think 7050 still has some useful points, and I think it's still going to be something that's supported and out there. And to be clear, this document that you're producing isn't deprecating 7050. It's not saying this is going away, stop using it, or anything else of that nature. It's just saying like this is the preferred method, especially for enterprise shops that are looking to try and build more scalable, more robust solutions. You should be looking at Pref64 and utilizing that sets of combined architectures. And especially if you have CLAP functions within the OS, and we're hoping that the Windows team is going to be releasing their WinCLAP functionality sometime soon here. When you get those sorts of client devices that can do all of that, then suddenly you can build a very scalable solution without that reliant DNS translation endpoint, which means we can get literal translations done. It becomes very, very flexible. This has already been proven at scale with the mobile operators, right?
Yep.
All the mobile handsets that run on, all the big mobile providers all do this today. So if there was any brokenness or problems, we would have discovered that quite a long time ago. I think we're in good shape there in terms of that side.
Yeah, so I just thought of one other advantage. This is something that we were kind of messing around with in the lab, which is when you are running Pref64. Now, this is particularly common in like K-12 schools in the US where they have like a DNS service that they pay for, like what used to be OpenDNS, now Cisco Umbrella. They offer a filtering service that's based on DNS that you can buy from them that's tailored towards like educational institutions.
Yeah, that particular market.
If you're doing Pref64, you can continue to use those. And, all your RPZs and all the other things that go along with that filtering don't need to change. You don't need to pull any of that in-house. You just turn on Pref64 and your DNS remains exactly the way it was.
Right.
And I think that's sort of a hidden advantage there because some entities don't run their own DNS. They might rely on, Quad9 or Cloudflare or whatever else. They don't need to change anything at this point. They don't need to pull that and spin up a new service. They can just turn on Pref64, and as long as they've got their PLAT, their NAT64 device in the path or available to them routing wise in their topology, then you're done.
Yeah. What's really interesting, correct me if I'm wrong, but I think Cloudflare provides like a NAT64 service. So you can even use an external, you don't even have to run it yourself.
Yep.
Which is sort of cool.
Yeah, Cloudflare and Google both do, I think. They use the well-known prefix, and as long as your PLAT is available using that, it'll just work.
Yep. Well, very cool. I think this is a good information for everyone. We're trying to keep everyone current about what's really going on around V6. That's part of the goal for the podcast. So hopefully this is about as current as it gets. It's still baking in the oven.
Yeah, and send us your questions.
Yes, definitely. If you want to send IPv6 Buzz stuff, if you have any questions for us, you can go up to the page on packetpushers.net/FU, which stands for follow up. And you can send questions directly to us for the IPv6 Buzz. We'll try and answer as many as we can on the show. And if they're not too technically specific and something we can get a guest on for, we'll try and get a guest on to address them directly. But Nick, thanks so much for filling us in on what you have going on here. And, definitely let us know how the outcome comes after the next ITF. And hopefully this pushes forward and it'll just be an informational standard out there for folks to make good use of.
Here's hoping.
Just for everyone in the show notes, we'll have the links for RFC 7050, 8781, and then the current data tracker for the draft that is being proposed.
We can also add, so all this is being developed in the public on my GitHub repo. So if you want to provide PRs, I'll be happy to read them. We can put that link in there too.
Cool. All right. Well, there you go, everyone. More interesting things to chat about. We'll catch you next time. Thanks for joining us for this episode of IPv6 Buzz. If you've got feedback or follow-up on this topic, send us a message at packetpushers.net/FU, where FU stands for follow-up. We'd love to hear from you and continue the conversation.
Also, at packetpushers.net, you'll find a range of other deep dive technical podcasts for IT pros.
There's a whole lot more on the Packet Pushers site as well, such as tutorial videos and a community Slack channel where you can talk with industry peers and experts. So whether you're deep in your career or just starting up, Packet Pushers is the place to go to grow both your skills and your personal network.
So long and until next time, we'll see you on the IPv6 internet.